AWS Lambda Concurrency. Lambda concurrency is the number of concurrent executions of your Lambda function code at any given time. Concurrency is subject to limits at the region level. The default concurrency limit for Lambda is 1,000 executions per account per region. You can increase the limit by submitting a request in the Support Center console. When your function is invoked by an event source, Lambda provisions an instance of it to process it. When the function code finishes running, it can handle another request. If the function is invoked again while a request is still being processed, another instance is provisioned, increasing the function's concurrency. In this example above, it shows the number of Lambda concurrency is increasing from 1 to 3. Reserved and unreserved concurrency. Within your account's concurrency limit, you can configure to reserve a portion of your account level concurrency limit for a given function. This reserved concurrency guarantees that it can always reach a certain level of concurrency. The reserved concurrency is also the maximum concurrency for the function. The remaining are the unreserved concurrency. All of your account's functions in the same region without reserved concurrency share the pool of unreserved concurrency. There are two key reasons for reserving concurrency. You can prevent a specific function from consuming the majority of the concurrency capacity available. Without reserved concurrency, other functions can use up all of the available concurrency, preventing your function from scaling up when needed. Or, a service could consume too much concurrent capacity and overwhelm downstream services or databases, which could cause failed executions. Here's a chef analogy example. There is a maximum of 10 chefs available for cooking or executing in this restaurant's kitchen. The total maximum concurrency limit is 10. If the Lambda function doesn't have enough concurrency available to process all events, additional requests are throttled. This means while all the 10 chefs are cooking, the 11th order will be ignored. Based on the food order's requests, only 7 chefs are required to cook at this time. The consumed concurrency is 7. After a chef finishes cooking the dish, the chef returns to the concurrency pool and will be available immediately to cook again upon requests. For example, in this restaurant, chicken is today's special. Chicken orders have become very popular. You decide to assign 4 dedicated chefs to cook chicken dishes only. The reserved concurrency for the cooking chicken function is configured to be 4. The other chefs handle all the other food orders, except for the chicken orders. The unreserved concurrency is the remaining 6 chefs. Since all the chefs are cooking at this time, the consumed reserved concurrency is 4, while the consumed unreserved concurrency is 6. Let's look at another scenario example. There are 3 chicken orders requested at this time, therefore only 3 reserved chefs are required. The consumed reserved concurrency is 3. There are still 1 reserved chef available to cook chicken. Similarly, at this time, only 4 chefs are required to cook the other requested food orders. Therefore, the consumed unreserved concurrency is 4. 2 unreserved chefs are still available. You can see in this simple analogy how you can reserve concurrency to meet your needs. In summary, Lambda concurrency are concurrent executions that help you to scale and meet traffic demands and requests with little or no need for capacity planning.